In this video, I'm going to show you how to use the plot function, which is a really great generic function in R that creates a different kind of plot depending on the type of data that you give to it. So to start showing you how that works, I'm just going to type plot, that's the name of the function, and then those smooth parentheses, and then give it the name of my data set, which is LA bike, and the $sign. I'm going to hit the tab key to scroll through my variables. And I'm going to choose this variable type and then hit enter. And you see that because I gave it this sort of categorical data that only had a few possible options, it automatically created a bar chart for me. And so this chart shows me that for observations that said bike lane, there were 5 of those, a few more bike paths, a few more bike routes, and there were 20 that said none. And if you scroll through the data, that kind of makes sense because I see a lot of places where it says none in the type column. Another thing that you can do is, I'll hit the up arrow here and just change my variable. You could do the plot of a numeric variable like this bike count, and now I get these dots. Because I only gave it one numeric variable, it's plotting that variable, the bike count PM, against the index. And the index is just the row in the data set. So this isn't a very interesting plot, but it does let us see that there's one value that's really big, and it looks like it's maybe between 15 and 20 for index values. So if I scroll down and I look here, yep, it looks like number 16 is 977 in that column. So that's what that observation is right there. A more interesting plot might be to, again, I'll hit the up arrow, put a comma here, and then give it a second variable. So like LA bike $sign, and hit the tab and scroll down to ped count PM. So this one is plotting 2 variables against one another, and then it puts a dot at the intersection. So maybe we'll try and find this one. So it's got a really high ped count and a bike count of maybe 250 or something. So let's see. I see some high ped counts here. Like here's one that's more than 2,000 or almost 2,000, but that's probably this one. Let's see. We need to find one that's really enormous. Oh, here it is. So 3,806 and 220. So it's out 220, up 3,806, and that's that point. So it's just doing that for every single pair of variables for each observation, and it's plotting a point. Another thing that you could do is you could use the plot command, and you could give it sort of a categorical variable and then a numeric variable. And when you do that, it automatically creates a box plot for you. So this plot is showing you the median and then the quantiles of the bike count for each of these different types. So we see that for observations that said bike path, the median number of bikes that were observed is maybe, I don't know, 150 or something. And the maximum number of bikes that was observed is around 400. And we can see that for observations that were marked bike route, the median is much lower. For none, it's sort of in between. And bike lane and bike path have almost the same median, but then the boxes are different, so the distribution is different for the variables. And bike lane has this one outlier. So that's kind of interesting. One other great thing about the plot command is that it lets you change almost everything about the plot. So if I wanted to go back to my previous example and I wanted to change the color of those circles, I could say COL, call, short for color, and then put an equal sign, and then the double quotes, and in the middle of the double quotes I could write the name of a color, like blue. And when I hit enter, all of those circles are now blue. Another thing that I can do is change the shape of the circle so that there's something else. And the way you do that is by using the PCH command. I don't have an easy way to remember this, but Again, you use the equal sign, and then you give it a number between 1 and I think 25. So let's try like 7. Okay, so that made it into boxes with X's in it. And we could try 5, and that's diamonds. Circles again. Anyway, you can play around with this and try it out. It'll give you different ways to plot the points. Another thing that you might want to do is make the labels on your axes a little bit better. Right now we're just using the R variables, but we might want to have words that mean a little bit more to people. So the way to do that is to use the parameter xlab, short for xlabel, and again you put the equal sign and the double quotes, and then we choose what we want it to say along the x-axis. So I'm going to say bikes, and then when I hit enter, that changes to bikes. I'll hit the up arrow and modify this again, put a comma. And then the next parameter is ylab, short for ylabel, and I'll put pedestrians here. And then if you wanted a title for the whole plot, again I'm going to hit the up arrow and put a comma. The parameter is called main, like the main title for the plot. And I'm going to put scatter plot of bikes and people. And then when I hit enter, the title appears on the plot. And almost all of these parameters work for all plot types, so you can use these skills in a lot of different places. A final thing that I want to show you is how to get help about plots. So what you do is you type help, plot, and then you hit enter. You have to choose this second option, generic XY plotting, and then you get the help documentation. As always, what I usually do is scroll down to the arguments, and then it tells me what kinds of arguments I can give to this function. So it says you could give it an X, you can give it a Y, which is optional. Remember we did just type by itself, or just bike count PM by itself. Or you can give it both an X and a Y, like when we did bike count and ped count, or type and bike count. And then it lets you choose a type. It's showing you that you could choose points or lines, things like that. Here's main, xlab, ylab, things like that. And then the other parameters that we were using, like the col, col, and pch, those are in the par documentation. So I can click here, and it'll show me the graphical parameters options. So there's a lot here. Again, I like to just scroll down and start reading the documentation where I see parameters. And this has tons more options that you could use if you wanted to customize your plot. If you want to change the background color, or change the size of the points, or change the dimensions of the plot, or the font for the text, anything like that, you can read through the documentation and get to change things. Oh, here's a really useful one that I haven't mentioned, LAS. Again, I don't have a great way to remember this, but LAS lets you change the direction of the labels on the axis. So to show you this one, I'm just going to go back to my type example, and remember that's what it looked like. So if I hit the up arrow and add LAS equal 2, now you see that the labels rotated so that they're kind of going down from the plot instead of along the bottom of the bar. And that can be really useful if you have a lot of labels that you want to fit in. There are a couple great features in RStudio that will help you with your plots. So one is that in the plots pane, you can click this zoom button and a larger version of the plot will pop out so you could look at it more carefully. This is maybe most useful if you have a lot of points or something, but I really like it to be able to see a nice big plot when sometimes my small pane isn't enough to see the whole thing. There's also this arrow which lets you scroll back through your previous plots. And then there's this export button. So if I have a plot that is totally finished and I love the way that it looks, so maybe this one I've got all my axes labeled, I've got the colors, everything, then maybe I'll want to save it and put it in a PowerPoint presentation or something. To do that, I click the export button and then click Save Plot as Image. And this lets me change all sorts of options. So maybe I can choose the file format. I'm going to just stick with JPEG. And then I can change the file name. So maybe I'll call this bike people scatter. And I can also change the aspect ratio. So right now it's almost square, but I could make it much skinnier and then update the preview and see what that looks like. But I think it would look better if it was totally square. So let's try that and update the preview. This looks perfect. So now I'm just going to click Save. And now when I look in my Files tab, I see that that file has appeared. So if you wanted to bring this to your desktop on your computer so you could put it into a PowerPoint presentation, for example, you just click the checkbox, go to More, and click Export, and then click Download. Now I'm on a Mac, so it's giving me this pop-up. I'm just going to say Save File, and now it's appeared in my Downloads file, and I could open it on my computer if I wanted to. So it looks just like it did on RStudio, but I could use it on my computer now. So to summarize, I have shown you how to use the plot function to plot all kinds of different data. Depending on the type of variable that you give it, it creates a different kind of plot, and you can customize the way your plot looks using different parameters like call to change the color, PCH for the shape, xlab and ylab for the labels, main for the main title, and LAS to rotate the labels. Then I showed you the back and forth arrows to scroll through your plots, the zoom button to see a larger version of your plot, and the export button that will let you save your image so that you could use it in another document. Perhaps most importantly, I showed you how to use the plot function to type help plot and to read more about all the options that are available to you.